All right. Well, this is not a substitution problem. Would you like me to move to the ones that are substitution problems?
No, because I have a question about this one. So,
Okay.
my question is, why is 5/4x to the fourth negative?
Are you referring to this one right here?
Yeah.
Okay. So if we just look at this part right here, the integral of 5x to the minus 5, you always add 1 to the exponent.
Yeah.
And then you divide by the new exponent, which is the same thing as this exponent.
Oh, okay.
So that gets you the 5 over negative 4, x to the negative 4 power. And then it's just a matter of like, how do you want to write it? So in the solution here, they move this up, and then they move this x down. So it's there's a few sort of intermediate steps here to get to the final answer.
Okay, that makes sense. We can move on.
All right. Should I move to some substitution problems?
Yeah, that's fine.
Okay. I see one at 12, 13.
Yeah, 12.
Let's start with 12. Okay. All right, decide on what substitution to use. Okay, so the rules that I've sort of said is that exponents, under roots, parentheses, these are all sort of things you're looking for your u substitution. So this is your u substitution. Your u is minus x squared plus 6. And then you immediately take a derivative. So it's du equals minus 2x. And there's always a dx on the right side. And then the technique that I've mentioned a few times, which I think is good, is to solve for dx. So you're going to divide both sides by negative 2x. So dx equals du over negative 2x. Right? And then you go back and you rewrite the integral, but then you substitute in for what you know. So you're always going to substitute in for dx and for the thing you made the u for. So you don't have any substitutions for 15x, but it's the square root of u. That's you're always going to substitute in for this thing, and you're always going to substitute in for dx. So it's du over minus 2x. And this is really critical. If you've made the correct substitution, then the x's will cancel. You will not see any x's, or there's no x's otherwise. And we have made the correct substitution here because this x cancels with this x up here. And this becomes negative 15 over 2 square root of u du.
Okay.
Please let me know if there's something in here that you'd like clarification on or explanation again for.
No, that makes sense. It's just kind of weird, you know?
Yeah, the problem with u substitutions is you can guess wrong and you make the problem worse, or there's a lot of things that you're choosing a path that may not be correct, and it's tough because it's frustrating. So this line here is written as, a better way to write it is u to the 1/2 power.
Okay.
So when you take the derivative, when you take the integral, you add 1 to the exponent, and your new denominator is 1/2 plus 1, and then you still have this minus 15 halves plus c, and now it's just a matter of simplifying. So you have minus 15 halves u to the 3 halves over the 3 halves power. Whenever you have a fraction on the bottom, you multiply by the reciprocal. So this is really, if it's 3 halves here, that means it's 2/3 times minus 15 halves u to the 3 halves plus c. So the more of this that you can do kind of without rewriting, the better, but the 2's cancel. Negative 15 goes into 3 5 times. So you have negative 5 u to the 3 halves plus c, and your u, if you recall, was minus x squared plus 6. So this becomes minus 5 parentheses minus x squared plus 6 to the 3 halves power plus c.
Okay.
So let's look at 13. 13 is another u substitution. Okay. The point here is to figure out the correct u substitution. It is what is in parentheses, minus x squared minus 8, and you take a derivative, both sides. So this is minus 2x, and this is 0, and then you put a dx with it. So then you solve for dx. You divide both sides by minus 2x, so dx equals du over minus 2x. So we're going to rewrite the integral. And you're always going to substitute your u in, and you're always going to substitute your dx in. So this becomes the integral x. Your u is here, so this is u cubed, and dx is du over minus 2x. If you've done this correctly, you shouldn't have any x's when you're all done simplifying.
Okay.
So notice this x cancels this x. This 2 is on the bottom, so it's the integral negative 1/2 u to the power of 3 du.
Yeah.
So with the u here, it's you add 1, new bottom, plus c. This is a 4 on the bottom, so you have negative 1/2 u to the 4th over 4. The exponents always match, plus c. So it's negative 1 over 8 u to the 4th plus c. And your u this time, your u again was minus x squared minus 8. So you're going to substitute that back in.
Okay. We can move on.
All right. Looking for any others. Okay, 23 is a u substitution problem, so we can do that.
Okay.
All right, just snipping it in. All right, it says evaluate the integral. So this time it has these bounds on there, and that's just an extra step at the end. You don't have to, it doesn't change anything that you're doing for the u substitution. You know, we're gonna just ignore those also. So we're just gonna look at the integral of this. So your u here is the exponent. It's everything in the exponent, minus x squared plus 5. And then you want to take a derivative. Du equals minus 2x dx. Wow, a lot of these are the same.
Yeah.
Dx, you solve for dx. Dx is du over minus 2x. So we go back to the integral here, and you want to rewrite it with as is, and you always substitute in for dx and for u. You always figure out how to use those. So integral x e to the u, because your u is all of this, and your dx is du over minus 2x. And I've said it now, this will be the third time. If when you're done, you have no more x's, or there weren't any to begin with, then you know you've done it correctly. The x's do cancel. That negative 2 is on the bottom, so it's negative 1/2 e to the u du.
Okay.
So the integral of e to the u is itself. So this becomes negative 1/2 e to the u plus c. But this is called a definite integral. So there is no plus c this time. But this is kind of like where we were at in the previous problems. Your u is minus x squared plus 5. So this is really minus 1/2 e to the minus x squared plus 5 plus c. But again, it's a definite integral. So we have to do something slightly different at this step. So the whole time it had these bounds. It had negative 3 to 3, negative 3 to 3. So what that does, or what that adds in this problem, is you have to evaluate the integral from -3 to 3. And if that's something you haven't seen,
No,
we
I
should,
haven't.
okay, great. So that's the next step here. You have to first evaluate at the upper endpoint. So it's -1/2 e minus 3 squared plus 5 minus -1/2 e, and then this is minus parentheses -3 squared plus 5. And see if you get some numbers. So this is -9. You square before you negate, plus 4. So this is -1/2 e to the -4. This negative goes with this negative, so you have +1/2. This becomes also e to the -4. So it looks like it becomes 0.
Okay. How do I know if it's a definite integral? Does that mean if it has bounds?
If it has numbers, yeah. If it has numbers, it's a definite integral,
Okay.
which means
So
you
if it's a definite integral, it has numbers, and that means that there's no c.
there's no c. That's right.
Okay, we can move on.
All right, I'm not seeing any more substitution integrals. I'm just seeing other stuff, lots of other stuff.
Okay, we can just do whatever. It doesn't really matter what order.
Okay. 3, 4. Okay, yeah, I want to just give these to you in a little bit of an order. Just looking through these to see which one I would do next. This integration by parts, I know, is going to be really, it's usually very frustrating, but we can get to that. Okay. They're okay. So we haven't done 9 yet. I guess we'll do 9. Okay, so 9 kind of is a substitution problem. It does say to use substitution. This is number 9. Sorry. The substitution here is what's in parentheses, 4x plus 5. So your du is 4 dx. And you always solve for dx. Dx is du over 4. So you go back to your original integral, and you're always going to substitute in for u and for dx. You got to make sure those get back in there. So this is u to the -4 power, and then instead of dx, it's du over 4. So if all the x's are gone, if they either cancel, they're no longer there, you know that you've done it right. And this is much simpler than the one that we just had to look at. So here you got same thing here. So you're going to take -4 and add 1 to it over -4 plus 1. And because there's no bounds, it's going to have a plus c. So that's 1/4 u to the -3 over -3 plus c. And then the negative is going to come out in front. You're going to multiply the 4 times 3. So it's -1/12 u to the -3 plus c. Your u is 4x plus 5. So you want to back substitute that in. -1/12. 4x plus 5 to the -3 power plus c.
Okay, that makes sense.
So let's do a couple of definite integral problems. These are good to get comfortable with. We'll start with 17. I think 17. Yeah, 17 is a good one here to do. These all expect you to get like nice answers, not calculator answers. I think we might have done some calculator problems where I said use the numerical integration of your calculator, but it just doesn't always work there for these. So when I see something where x's are on the bottom, I would generally say to rewrite it where it's 8x to the -2 plus 3x times dx.
Okay.
The reason is that you want to be able to quickly use the power rule to do this. So this one is, it's 8x minus 2 plus 1 over minus 2 plus 1. This is 3x 1 plus 1 over 1 plus 1. And then there would be a c, but we have to evaluate it now from 1 to 3. So let's just deal with these exponents. It's 8x to the minus 1 over minus 1 plus 3x squared over 2. You're evaluating it from 1 to 3. So this is now, and we're going to rewrite this, it's really negative 8 over x, because x to the minus 1 power is 1 over x, plus 3 halves x squared evaluated from 1 to 3. Excuse me. All right, so now we're going to put in the upper end point. So it's minus 8 over 3 plus 3 halves 3 squared minus, and I like to put a big parenthesis here because everything's subtracted underneath. So it's minus 8 over 1, putting 1 in for x, plus 3 halves times 1 squared. So this is minus 8 over 3 plus, this is 9. 9 times 3 is 27 over 2. This minus goes in here, so it becomes plus 8. And this minus goes in here, so it's minus 3 halves. So then, like these two, they make 24 halves, which is really 12. And we have an 8 to go with it. So 12 plus 8 is 20. And then because this is a bottom of 3, you're going to want to rewrite this as 60 over 3. 60 over 3 minus 8 over 3 is 52 over 3. By this step here, though, you could just go to your calculator and do a math enter, and it'll give you the fraction that you need.
Okay.
So we'll do a couple more of these because these aren't meant to be difficult, but and you can do them in your calculator to check. But I know you got to show your work, so that's why we got to work through them to work through these. So let's go to 18. 18 is next here.
Okay.
And so like the answers I'm seeing that you have entered in, they look like they came from a calculator or an online program, and they're correct. They're just not what WebAssign wants. So we got to do what WebAssign wants.
Okay.
All right. So the one exception to what I said earlier, I said, okay, well, you should write this as 2x to the minus 1. The problem is that this is the exception. What is the integral of 1 over x? It's the natural log absolute value of x. So everything I just said applies except when it's over just 1x.
Okay.
Okay, so the integral here, the integral of x to the 1 is 1/2 x squared, okay, plus 2 natural log absolute value of x. And then you're evaluating that from 4 to 7.
And do you start from the bottom number?
Top. It's always top minus bottom. Okay, so let me work through that here for you. It's 1/2 7 squared plus 2 natural log absolute value of 7 minus, now you always like a big parentheses, 1/2 4 squared plus 2 natural log absolute value of 4. So now this first one is 49, so it's 49 over 2 minus 2 natural log absolute value of 7, or 2 natural log of 7 minus, so 4 squared is 16.
Wait, why is it minus 2 ln 7?
Plus, sorry, should be a plus there. This one is 16 times 1/2, so that's 8. This minus goes in here, minus 2 natural log absolute value of 4. So depending on what you've got here, you may be able to just get away with this. This 8 is really 16 over 2, and it's negative, so you can combine these two. That becomes 33 over 2. And then this is where it gets a little bit like, well, what do we do with this? There's so many things here that are not related to this course that go into this answer. This is correct, but for example, this 2 can come up here. So this becomes natural log of 7 squared, which is really natural log of 49. This 2 can come here, so it's minus natural log of 4 squared minus natural log of 16. And then you can combine these. There's a property that says it's whenever it's subtraction, it becomes division. So I don't know how much of this you would need, but that gets you pretty close to your final answer for that. And then one other was, I think WebAssign will probably accept something from earlier, but like I think WebAssign will actually accept this line up here, but you may end up feeling like you got to simplify more. Just look into that and see what it'll give you.
Okay.
All right, let's move on to another question. All right, 19 would be good here to do. All right. All right. Okay, so the integral here, the integral of 5e to the x is 5e to the x. Okay, so this is one of the most basic integrals, but you got the limits here. You got to evaluate it at minus 3 and 0. It's always the top minus the bottom. So this is 5e to the 0 minus 5e to the minus 3. Now, I know I usually put parentheses around this. You can, but it's only one term, so that's why I didn't include it there. So what will WebAssign accept? I think it'll accept this. E to the 0 equals 1, so this is really 5 times 1. Okay, so one possible answer is this is just 5 minus 5e to the minus 3. WebAssign factored out the 5, so that gives you 1 minus e to the minus 3. And then you can also rewrite e to the minus 3 as 1 over e cubed.
Okay, I think I got it like confused because I was actually subtracting 5e to the 0 minus 5.
Okay. And that may be what it is. I don't know, but when you put your cursor into the box, usually it tells you, an exact answer, and that means you're not touching your calculator generally.
Okay.
All right, number 20. We'll do number 20 next. All right, so evaluate the integral. Here we got minus 3 to 3, cube root of 4x that's given here. This is really the cube root of 4 times the cube root of x.
Okay.
Okay, and that's important here because you could make a u-substitution here, but because you can separate these things, this is just a number. So it's really like a constant that comes out. So you're really just doing the integral of this, the cube root of x, and the cube root of x is x to the 1/3 power. So you're really doing, this is a number, cube root of 4, great. Integral x to the 1/3 power dx. Oops, I'm sorry, I'm by that. So the power rule, right? We're going to add 1 to this exponent, x to the 1/3 plus 1 over 1/3 plus 1 cube root of 4. And then we're evaluating this from minus 3 to 3. Okay, so let's just get this top part. So this is the cube root of 4, x to the 4/3 power over 4/3. Whenever you have a fraction at the bottom, you multiply by the reciprocal. So it's 3/4 cube root of 4 x to the 4/3 evaluated from -3 to 3. All right, so all of this in front, these are just constants. So we haven't done this yet, but the only thing you really need to evaluate is this right here at the endpoints. That this is just comes along for the ride. So it's 3/4 cube root of 4 times, and then we're going to put this number in 3 to the 4/3 power minus 3 to the 4/3 power. And this is where it's like, okay, like, do we need to do more than this, or is this good enough?
We do not do like minus 3/4 times 3 root 4, and then like you don't do it all out. You just do the exponent.
Well, okay, so we need to know, like, well, what does this actually mean? This is the cube root of 3 to the 4th, so we can get a number out of that. This is the cube root of minus 3 to the 4th. We can get a number out of that also, but I think WebAssign will accept this. And like the skills here are kind of they're college algebra skills that if you've forgotten them, you could mess the problem up from this point. And so I guess I would just be very careful before I said, hey, you know, go ahead and always simplify these things for you.
Okay. All right, we can move on.
21, okay. 21 here. All right, evaluate the integral. So this 9 to the x is kind of like e to the x. The integral of this is itself, but you also have to divide by the natural log of whatever the base is. In this case, the base is 9. That's your a. So this is something you have to know, because you can easily mistake this as the integral e to the x, which it is itself, but there's also this little extra wrinkle to it. Okay. So the integral of 9 to the x is 9 to the x divided by the natural log of 9 evaluated from 0 to 1. So this natural log of 9, we'll just write each time, but it's 9 to the 1 power over natural log of 9 minus 9 to the 0 power over natural log of 9. Again, I think WebAssign will accept this, but like 9 to the 0 is 1. So you might see an answer like this. That probably will also be okay. But these are the same. 9 over natural log of 9, 1 over natural log over 9. You have 9 minus 1. You really have 8 of them. 8 over natural log of 9.
Okay.
All right, let's do 22, another definite integral. You will come to like these. You'll say these are the ones you want to see in the test after you've done them a few times. They're better than the substitution problems, I think. Definitely better than integration by parts. All right. So the challenge here is you could use a u-substitution for this, and you probably should. Okay. Your u, because you don't know what the integral of this is, but you do know that e to the u, the integral of that is e to the u. So if you can get this down to e to the u, you're good. Your u is the exponent, e to the x plus 3. Your du is minus dx. You solve for dx by dividing by -1, so it's du over -1. So you rewrite the integral, okay, e to the minus x plus 3 dx, and you're going to substitute for the u and the dx. So it's e to the u, and then it's du over -1. That negative comes out in front. So it's negative integral e to the u du. You know how to do this. That's e to the u plus c. Okay. But we have bounds, right? So we have to account for this. And we have a u. Your u is minus x plus 3. So it's minus e to the minus x plus 3. And then you're evaluating it from 0 to 3.
Okay.
Is all of this clear? Is there anything you'd like me to explain again?
No, it all makes sense.
Okay. Because after we do this, I'm gonna go back and make a comment on this. So we're gonna evaluate it at the upper. It's always top minus bottom. So it's minus e to the minus 3 plus 3 minus e to the minus 0 plus 3. Minus 3 plus 3 is 0, so this is minus e to the 0. Two negatives make a plus e minus 0 plus 3 is 3. E to the 0 is 1. This is minus 1 plus e cubed. You might see it written as e cubed minus 1.
Okay.
Now there's something that I'm sure you probably saw in class, and this may have been what you're referring to. What some instructors do is they change the limits of integration here.
Oh no, she doesn't do that.
Okay.
I've heard that. My other tutor that is free basically here,
Yes.
that they provide you for ASU, kind of ran me by that, and I was like, I didn't want to get into it because I just didn't want to confuse myself, and she doesn't teach it like that anyway.
Okay, that's a good strategy because it is very, very confusing if you're not used to it. Okay, so we have a choice here. We can do kind of these integration by parts problems, or we could just spend the rest of the time doing the non-integration by parts problems.
It honestly doesn't matter to me because I have another session on Thursday that
Okay.
we're gonna get through all of these problems. I'm pretty sure.
All right, let's I'm just gonna go through the non-integration by parts. It's a topic we should start with rather than ending with. I know we've got 15 minutes, but I don't want to try to, if it's confusing. So calculate the left Riemann sum for the given function over the interval using the value of n. Do you know if you only do left sums in this class?
Yeah, I think so.
Okay, so there's an interval from 1 to 5. And they give you an n. So you have to know this. You have to know that delta x is b minus a over n. And your b is a and b. Your b is 5, your a is 1, and your n is 4. So this is 4 over 4, which is 1. Now, why do you need this? Well, because you have to start at your a. You start at your a value, and then you have to add delta x. So that gives you to 2, and then you add delta x, gets you to 3, add delta x, gets you to 4, add delta x, and gives you to 5. So even though there's 4 n's, there's actually 5 numbers. But because you're doing the left sum, you only want these.
Yeah.
Okay. So the left sum is delta x, we use L for that, delta x times f of, in your case, it's going to be 1 plus f of 2 plus f of 3 plus f of 4 because of those 4 values there. You know delta x is 1, okay? So now all you've got to do is evaluate this function at each of these places. So f of 1 is 7 times 1 squared. That's the f of x right there. That's where I'm getting that from.
Yeah.
F of 2 is 7 times 2 squared. F of 3 is 7 times 3 squared. F of 4 is 7 times 4 squared. So you got to get these numbers. This is 7. This is 7 times 4. What's that? 28. This is 7 times 9. That's 63. And this is 7 times 16. I think that's like 112. So then your left sum is your delta x. Your delta x is 1. And then your f of 1 is 7. Plus your f of 2 is 28. Plus your f of 3 is 63. Plus your f of 4 is 112. And that's how you get 210 for this.
Wait 1 second. Okay, that's so weird because I did that. I'm trying to find where I did it. and that's why I got 203. I must have just multiplied wrong or something. Oh, no, maybe I just, no, never mind. Oh,
These
yeah,
are,
I actually did multiply wrong.
yeah.
Instead of 53, I put 56.
My experience is you don't ever have to round your answers on these. You might get one that's like a half or something for these questions, but always, take the time to double check those calculations. You'll feel a lot better. You'd rather miss the harder problems than miss one of these.
Yeah. Okay, that makes sense.
All right. Okay, so we're going to look at number 5. Number 5, it's when you know what to do with this question that I'm about to step in, it's let me snip this in here. You realize, okay, it's if I know the recipe, I know what to do. So whenever you see this question, you're going to integrate 9e to the x plus 8. You're going to take this and you're going to integrate it. Okay, so see if you can do that on your own right now. It's a pretty straightforward integral. See if you can come up with that.
So just 9e to the x plus 8x.
Yes. So the antiderivative is 9e to the x plus 8x plus c. Okay, and that's your function. That's your function. Okay. And again, there's a but here. The but is we don't know c. What is c? Well, c comes from this up here, this boxed in stuff. It comes from what's called an initial condition, or a point on the graph. So you know that when x is 1, when x equals 1, f of x equals minus 1. So we're going to substitute those values in. You're going to substitute 1 for x and minus 1 in for f of x. So that's minus 1 equals 9e to the 1 plus 8 plus c, and then you're going to solve for c.
So
let's
9e to the 1, is that, like, what is e to the 1 equal?
It's e to the 1. You keep it as this. So you subtract 8, so you get minus 9 equals 9e to the 1, and then you subtract 9e. And this is where I think it's uncomfortable. Is c, which is on the right here, is minus 9 minus 9e, and that's what it is. That is c. That's it's totally okay. So f of x was 9e to the x plus 8x plus c. You take this and you put it in for c, even though it looks and feels wrong. It doesn't fit your eye. It's okay.
Okay, so that's weird.
Yes.
You just ignore the 1 attached to the e?
Yes. E is a number, much like pi is a number, much like like the square root of 2 is a number. It just doesn't fit your eye. Like you're used to getting something that's nicer. This is probably the last math class you'll ever take, I'm guessing, but this is something you see all the time in upper division math. It's no big deal. It's just treated as okay.
Okay.
It's like your shirt, you want your shirt tucked in and it's out, and you're like, doesn't look right. That's just the way it goes.
Okay.
All right, so that takes care of that problem. There is, I think, one more like it. No, we'll just move on to the other ones here that I see. Okay, so we'll go to 27. Oh, that's odd. 27 doesn't snip in well. All right, so 27 is something to do with marginal revenue. Okay. All right, marginal revenue. The marginal revenue of the X box of cards sold is this. Find the revenue generated by selling items 101 through 1000. Okay. So this one, they're giving you the marginal revenue. They're giving you R prime. R prime is 200 e to the minus 0.003x Okay, so to find the revenue function, you have to integrate r prime, which means you're going to integrate 200 e to the minus 0.003x dx.
Okay.
Now this one is a definite integral because it says here they want to know what's going on from the 101 first box to the 1000th box. And this is where I think you can just go right to your calculator, because you've shown enough work here that you're gonna use that numerical integration technique that I showed you.
Okay.
We can also kind of we can also do that plus show a few steps by hand if you want. What do you think your instructor will accept or want, I guess?
Well, I don't know, because there's like usually 15 problems on the test, and there's like 1 through 9 is you don't have to show your work, and then the rest are the last.
Oh, you got that one, that instructor. Okay, yeah.
Yeah, so the last 4 are like you do have to show work, and that's what you're submitting, and a lot of times those are the word problems, and since this is a word problem, I'm thinking maybe, but I could just plug in the numbers and that would make it look like I showed my work, right?
Yes. So the thing here about yeah, you would want to maybe show a little bit more here if this was in that 10 through 13 section. So the integral of e to the u equals e to the u. But there's this number here, and this isn't quite e to the u. So the antiderivative of this is itself. Okay, but if you were to take the derivative of this, what would you have to do with this 0.003? It would come out front, right?
Yeah.
So to cancel it out, you have to divide by it.
Oh.
So that 200 comes here, and rather than us getting kind of really detailed in this, I think you just got to remember that these go in these positions. So the number just comes along, but when there's a number in front of u, and we can actually so let's say it's e to the ku. The integral of this is probably easy to remember, is e to the ku over k.
Okay. And then you plug in it 101 and 1000.
Yeah, so it's 200 over minus 0.003 e to the minus 0.003, but you're evaluating it from 101 to 1000. So that 1000 goes in. And then you put the 101 in here.
Okay. Okay. That makes sense. Do you know how many problems that we have left?
Yeah, I've not done 23 or 26 because they're kind of they're well, 23 is for sure integration by parts. 26 is a graphing one, but it's not too bad. 31 we can finish for sure. It's another calculator problem. Just 2 more.
Okay.
So you definitely want to queue up some more questions for next time. Or you can just say, hey, Matthew, give me some more like the ones that we've got here.
Okay.
All right, so the annual revenue earned by Walmart, it can be approximated by this function. They want to know the total revenue in this interval. So this is your A and this is your B. So you're integrating the revenue function from A to B. That's the total revenue. That's what they want here. So you're going to take your A was 0 to 14. Your revenue function 176, sorry, that looks like a negative, that's no good. E to the 0.079t dt, and you're going to integrate this. So I just mentioned this. If it's e to the kt, this becomes e to the kt over k. So this exponent here, you have to bring it down on the bottom, 0.079 e to the 0.079 t, and you're evaluating that from 0 to 14. So this is where you got to show the numbers going into the formula, but I would definitely tell you to integrate in your calculator. This is what you want to put in your calculator right there.
Okay.
Calculators generally just will not do you wrong at all in this part of the course. So
Yeah.
Times 14 minus 176 over 0.076 e to the minus 0.079 times 0. Actually, that's not minus, that's positive. Sorry. Handwriting got kind of sloppy here at the end. Apologize for that. Okay, and that is, it's whatever it is. Whenever the question says to round, you almost always know that you're going to use, this one says estimate to the nearest 10 billion. So that's the tens place. You can always use a calculator when it says estimate or round or.
Okay. How do you plug in that to your calculator?
The integral?
Do you still do the math 9 thing?
Yes, exactly.
So you just do 0, 14, and then
176 e 0.079 x dx.
Oh, it's that. So you don't put the 0.079 over. That's if you're showing work.
That's if you're showing work. Yeah, that's the like you have the calculator, like you're done. You just throw that in a calculator, you're done. But if you got to show work, everything down below here has to be included.
Okay. Perfect. I'll definitely I'll look through my review again and see if I can find more problems, but if the ones we haven't covered are the only ones that I need to work on, we can just like do some more practice problems, I guess.
Yes. Okay. All right. Well, thanks for scheduling. I'll send you the notes and the screen recording out shortly, and I'll see you next time.
Okay. Thanks, Matthew.
Have a good day. Bye now.